Hello everybody. In this video we will continue discussing separable differential equations, but now we will focus on those examples where we do not get an explicit solution. Okay, so we will deal with problems where the solution that we get is in an implicit form, and we will need to use some sort of graphing utility to visualize what the solution looks like. So for this particular example and for the next one after this, I will be using Desmos to demonstrate the solution graphically. Okay, so let's take a look at this example. We have y prime is equal to the rational expression 1 plus x over 2 minus y, and we have initial condition of y of 1 is equal to 1. So we're going to solve this equation by using the method described in the previous video. Okay, so what do we have? This is y prime of x is equal to 1 plus x over 2 minus y. Let's rewrite this as dy dx. We need to separate our variables in such a way that y is on one side, so we multiply by 2 minus y, and x is on the other side. Okay, so now we can integrate each side of this equation. Okay, the integration part of this problem is fairly simple. We get 2x minus 1/2, just kidding, 2y, minus 1/2 y squared. Okay, and then we get x plus 1/2 x squared plus c. Okay, so this is an implicit general solution. Okay, we have that constant c that we don't know, but now we're going to use the initial condition. Okay, so how do we use that? In this case, we plug in 1 for x and 1 for y. Okay, that is this condition right here. Okay, y of 1 is 1. Okay, so then we get what? So this is going to be 2 times 1 minus 1/2 1 squared is equal to 1 plus 1/2 1 squared plus c. Okay, and if you solve this simple equation, you get that this constant is 0. Okay, so our solution, particular solution, looks like 2y minus 1/2 y squared is equal to x plus 1/2 x squared. And it might seem like we're done, but not quite yet. Okay, so first let's go ahead and graph this. I'm gonna go ahead and use Desmos, and I already plugged this in into my Desmos, so you see that you get this circle. Okay, but circle is not a function of y or x, right? So it doesn't pass the vertical line test. Remember, the solution to your differential equation is a function, so we need to determine which part of this circle is actually the solution. Okay, so we need to go back here and take a careful look at the original equation. Okay, so the original equation, what does it say? It says that y prime is equal to 1 plus x over 2 minus y. Okay, so this means this differential equation is defined for values where y is not as equal to 2, right? So y cannot be equal to 2. Otherwise, we have division by 0, which means we need to exclude points where y is 2. Okay, so if we take a look at our circle over here, it looks like it's on this horizontal line, y is equal to 2, do we have any points on the circle that intersected? And the answer is yes. So there's 2 of them, right? So that means we should be able to find the x coordinates. Okay, so what do? We plug in y is equal to 2 into this equation. This equation right here, I'm going to mark it as star. Okay, into star. So what you're going to get, x plus 1/2 x squared is equal to what? 2 times 2 minus 1/2, 2 squared. So this is going to be 2. So we're basically solving this quadratic equation. 1/2 x squared plus x minus 2 is equal to 0, which we can write as x squared plus 2x minus 4 is equal to 0. I just multiplied both sides of the equation by 2. Okay, and using quadratic formula, I'm going to let you fill in the gaps here, but you should get 2 distinct roots, and they're -1 plus or minus root 5. Okay, and you will see I already marked them here on my graph, but let me put them back here. So these are these points on the circle, okay, with the coordinate 2 for y and then -1 plus minus root 5. Okay, so these are the points that we need to exclude from the solution. So now the question is, which branch of the circle, which part, top or the bottom? Okay, which one is it that we're going to accept as the solution to this differential equation? And that all depends on the initial condition. Okay, the initial condition will tell us which one to pick. The initial condition says, okay, y of 1 is 1. So here's this point right here, which means we'll look at the point, where is it? 1, 1 is on the lower part of the circle. So your entire solution is what? This lower part of the circle, not including the points -1 plus or minus root 5, 2. Okay, so we can make a quick sketch here. What is actually solution? What is the solution to this equation? Okay, graphically, it's going to be the circle, right? A lower part, excluding these points right here. Okay, so this point right here would be -1 plus root 5, 2. This one right here is -1 minus root 5, 2. And then 1, 1 sits somewhere here. That's your initial condition. Okay, so let's go through this example real quick. What did we do? We solved this by using separation of variables, right? So integration is fairly simple. We get the solution and it's an implicit form. Okay, we use the initial condition to find our constant. Okay, we go back and say, wait a minute, we have a discontinuity at y is equal to 2. Okay, which means we need to exclude some points from the solution. So we find them algebraically. And then you take a look at the graph and see, okay, what's my initial condition? 1, 1. Okay, so this is the part of the circle that we will take as our solution. Okay, so that's your one example. I will go through another example of this type in my next video. Thank you for watching.